So you've got an inverse function to find here, but it's a quadratic in standard form. And the usual technique of just applying inverse operations to find, as you normally would do, replace that with y, and then rearrange so that you've got x equals some function of y, and then once you've got that, change all the y's to x's and change the x to f to the minus 1 of x, doesn't work, because there's no clear path to end up with an expression x equals just by doing inverse operations when you've got a quadratic in standard form, which is this form, this ax squared plus bx plus c form. There is, however, a way to do that if you've got the quadratic in completed square form. So with these questions, if you've got to find an inverse function and you've got a quadratic in standard form, complete the square. And then you can just unpick, and that's what we'll do here. It is also possible to put it into the quadratic formula, but it's more fiddly, and you're going to have to learn to complete the square anyway. It's very useful to be able to do, because in completed square form you can sort of read off information about the curve. So I'm not going to bother with the quadratic formula method. So I'll start off with y equals 3x squared minus 12x plus 7. I'm not finding roots here, so I'm not doing any equals 0 or anything like that. All I'm doing is writing the same quadratic in a different form. The first thing I need to do is factor out this 3 from the first part of the expression. So that gives me 3x squared minus 4x plus 7. And then I'm going to take this bit here and I'm going to complete the square just for that. So that gives me 3. I'm going to end up with something in brackets, and that something in brackets is going to be x minus 2 squared. I'm always going to halve this term here. So that's nice and easy. If I were to multiply this out now, x minus 2 squared, I'd get x squared, I'd get minus 4x, but I'd also get a 4 that I don't want. And that's the 4 that I now need to take off. That's the end of my bracket, so now I've got my plus 7. And I think if you're not sure about completing the square, it's worth bearing in mind that this expression here, the one with the outside brackets, is equal to that expression there. Okay, so I haven't changed anything. I'm now going to distribute the 3 back into the outer set of brackets. So that gives me 3x minus 2 squared minus 12 plus 7, and that's 3x minus 2 squared minus 5. And now I'm in completed square form, and now I can just, it's kind of as if, this is an easier question now, and I can just unpick and solve for x. So I'm going to write that down, solve for x. And let's go. So y plus 5 now. So this is the inverse operation that I'm doing first. Add 5 equals 3x minus 2 squared. The next thing I need to do, because of BIDMAS, it's the division by 3 to get rid of that. So y plus 5 over 3 equals x minus 2 squared. I'm going to bring the x over here now, so x minus 2 equals, and because I'm square rooting, I can either have plus or minus the square root of this thing here, y plus 5 over 3, and finally x equals 2 plus or minus the square root of y plus 5 over 3. But looking at the question, it's asking me, only for the function only exists for x less than or equal to 2. So I want to reject here the solution that gives me a value greater than 2. And since I've got a 2 here, I only want to keep the minus part. The plus part is going to give me values that are not in the domain of the original function. So I can now just write f to the minus 1 of x equals, so this is what you do in general. I'm going to take this side here on the right and replace the y's with x's, and take this side on the left and replace the x with f to the minus 1 of x. And that gives me 2, and I only want the minus. And then I can write this. This is now x plus 5 over 3. And that's my final answer.